Hi guys, so for this lesson or this video what we're going to do is going to look at probability for equally likely outcomes. So this is just in the cases where the sample points are all equally likely. So an example for this would be if I pick a card at random from a standard pack of cards, they're all equally likely to be chosen, all 52 of them. If a student is picked at random from those in your class, then they're all equally likely to be picked. And the other one there they've given is two different digits chosen at random. Each possible choice of two digits are equally likely. So how do we work that out? This is the sort of thing that we looked at in second year, guys. The probability for equally likely outcomes is the probability of an event happening is equal to the number of favourable outcomes over the total number of possible outcomes. And that's the way you've got to think of this. So let's have a look at an example. It says here a bag contains 20 discs marked for the whole numbers from 1 to 20. And the first part is if one disc is picked at random, find the probability that the number on the disc is divisible by 3. So remember what we said we wanted to do. We need to work out the total number, and we also need to work out the number of favourable outcomes that we want as well. So hopefully you can see that the total number of outcomes is equal to 20. We're going to call that n. And the favourable outcomes, so the favourable outcomes, we have, if it's divisible by 3, then we have the set of 3, 6, 9, 12, 15 and 18. If we add them up, we can see we have 6 of them, so that means that r is equal to 6. That means we're now going to work out our probability of the event happening. So the probability of the event happening is equal to the number of the r's over the number of the n's, which is equal to 6 over 20, which is equal, in this case, to 3 over 10. And that question now has been answered. Let's have a look at part 2. So if 2 discs are picked at random from the bag, what is the probability of getting one even number and one odd number? Okay, so let's deal with the fact that we're looking to find out the total number of ways this can happen. So the total number of outcomes. And this is going back to our previous chapter. So hopefully you can see here that we have 20 outcomes, or the n is equal to 20. And what we want here is we want to choose 2. It doesn't matter what order they're in, so we just want 20, choose 2. And if you put that into your calculators, you'll find that that's 190 different ways of that happening. The next thing we want to do is we want to find the probability of getting one even and one odd. Okay, so again, what we're trying to do is we're just trying to work out the number of favourable outcomes. And if we just put odd and even there, you can hopefully see that we have 10 odd numbers and we want to choose one of them. We also have 10 even numbers and we want to choose one of them as well. As you can see here, as I said before, that this here will add up to 20, which is from here, and we are choosing 2, which again will make sense there. So the odd, there are 10, choose 1, even 10, choose 1, and that will turn out to be 10 times 10, which will be equal to 100 different ways of this happening. So now what we have, we just need to work out the probability of this event happening, is equal to, well, it's just our r over our n. Remember, this is our r, this is our n. If we work that out, we get 100 over 190, which is equal to 10 over 19 when you simplify it. It's really important that you're really happy with the last couple of exercises that you've done in the last chapter, because we're going to be using that all the time in the next few chapters. Okay, so make sure you're happy why this is 10, choose 1, this is 10, choose 1, why this is 20, choose 2. Otherwise, you're going to find it very difficult to move on from here. Okay, we'll have a look at the next example. So example number 2 here says a bag contains 4 red, 3 blue and 5 white. 3 markers are drawn at random from those in the bag. Brian bets that all three markers will be of different colours, whilst Katie bets that all three markers will be of the same colour. Determine who has the greater probability of winning this bet. Okay, let's have a look at Brian first. So Brian, good old Brian. So you can see here, I'm just going to write so that we know we've got red, we have 4, we have blue, we have 3, and 5 for white. So just so I know what's going on there. So it says 3 markers are drawn at random from those in the bag. So Brian bets that all 3 markers will be of different colours. Okay, so the first thing we need to do is we need to find out the total number of ways that we can choose the 3 discs. So let's add up the red, the blue and the white. And if we add them up, you can see we've got 4 plus 5, which is 9, plus 3, which is 12. And we want to choose 3. So our n here is equal to 12, choose 3. And if you put that into your calculator, guys, what you'll end up with is 220. The next thing we need to do for Brian is we need to work out how many different ways that we can choose that we get 1 marker from each one, okay? And that shouldn't be too difficult. So we look at the red, we look at the blue, we look at the white, and you can see here we have 4 to choose from, but we need one of those red ones. We need 4, choose 1. For the blue, there's 3 of those counters, and we need to choose 1. And for the white, we need 1 from the 5 that we have in the bag. If we do that, guys, we get 4 times 3 times 5, which is equal to 60. Now the probability of this happening now, so the probability of this event here happening is equal to, remember this is our n, this is our r, and it's r over n, which is equal to, in this particular case, 60 over 220. If you simplify that, guys, you should be able to take the zeros off, so 6 over 22, and then you can divide everything by 2 to get 3 over 11. So the probability of there being 3 markers of different colours is 3 out of 11. Okay, let's have a look at Katie. So Katie reckons that all 3 markers will be of the same colour, which means that she can have 3 reds or 3 blues or 3 whites. So there's a lot more work to be done here in order to see what's going on here. Now, hopefully, you'll be quite happy that our n here has to be the same, because again, this is all coming from 12, choose 3. So all we're doing here is we're doing 3 different sums, and because we've got the or, and or in probability means add, we're going to work out these 3 things, add them together, and see is it bigger or smaller than this 3/11ths. Okay, so 3 reds. So 3 reds, that means, remember, if we do the R, B, W again, R, B, W, R, B, W, and we can just go through. So this one here, we want 3 reds, so we want 4, we want to choose 3, which means that now we don't want any other colour to come up. So from the 3, we want to choose 0. And from the white ones, of the 5 of them, we want to choose 0 from there. The or means plus. And here what we now have is red. We don't want any reds this time, so it's 4, choose 0. We want all of those 3 blues, so it's 3, choose 3. And the whites, we don't want any, so it's 5, choose 0. The or again means plus, and what we have now is the reds. Again, we don't want any reds. We don't want any blues. And what we want now is all the white ones, so we want all 3 of those counters to be equal to white. So 3 of the 5. 5, choose 3. We're then going to work all of them out. 4 plus, this is going to be 1, plus this is going to be 10. So if you work all them out, you're going to get equal to 15, which means that my R is going to be equal to 15. My N is going to be equal to 220, which means that the probability of 3 reds or 3 blues or 3 whites is going to be 15 over 220. And if you simplify that, you can divide everything by 5, you get 3 over 44. it's quite obvious that you can see that 3 over 11 is greater than 3 over 44. Therefore, Brian has the greater probability of winning. The last example for you now on the next slide. So here we are being given the information that 2 dice are thrown. What's the probability that we get a total, which is a prime number? And for this one, we're going to actually draw a sample space. Now, we should realise how many numbers or what our hash n is going to be here, because for the first die, we have 6 possible outcomes multiplied by the second die, which is 6 possible outcomes, which means we should be expecting to get 36 possible outcomes altogether, and that there is going to be my hash n. But what I'm going to, like I said, what I'm going to do is I'm going to draw a sample space. So I'm going to do the first die, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Make it into a bit of a table here. And it says, what's the probability that we get a total, which is a prime number? So we're just going to add these up as we go along. So just change colour. 1 plus 1 is 2. 1 plus 2 is 3. 3 plus 1 is 4, and so on and so forth. I'm sure you'll be quite happy, guys, to see how this works out. I'm just going to fill it all out whilst I'm talking to you. 5, 6, 7, 8, and 9. If you keep adding them, and you've got 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, and 12. So again, if you add them up, you can see if you counted all the blue things that we have here, there'll be 36, which is what we're expecting, because we've got 6 by 6, which will give us 36 different outcomes, or possible outcomes, I should say. And we are asked to give a total, which is a prime number. Now, the only thing we can actually do here is just work them out by circling them. So let's just go through and circle all the prime numbers that we know. So 2 is a prime number, 3 is a prime number, 4 isn't, so I'm not going to circle that. 5 is a prime number, 6 is not a prime number, 7 is, 8 isn't, 9 isn't, 10 isn't, 11 is a prime number. So all we can do now is count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So hopefully you can count those circled, and we can say that from that we know that hash of the R is equal to 15. So now we can write the probability of the event, which is a prime number, okay, is equal to 15 over 36, and we can then divide divide top and bottom by 3, so we're going to get 5 over 12, and that's it, we're finished. So guys, hopefully a lot of this is making sense for you. Again, if it isn't, please contact me via email or on the Google Classroom. The exercise is exercise 22.2, and it's on page 23.